Okay, so thank you for that. So some numbers associated with McMaster Engineering, and you may know some of these numbers, or they might be a bit of a surprise to you. So we have somewhat over 5,000 undergraduates in total, and about 1,000 graduate students. So about one graduate student for every 5 undergrads. 180 faculty members, 155 or so. Actually, that's got numbers gone up a little bit, who are active in terms of conducting research, and then there's other faculty who specialize in teaching. And about the same number of administrative and technical staff who help us to do that. Currently, we have 22,000 alumni around the world. So each year we spend about $40 million in research, somewhat greater than that. That number is roughly doubled in the last 6 years. And if the pandemic had not come, we probably would have gone over 50 million this year. What that means, there's a terminology called research intensity, which is how much money we spend per professor. And you can see it's a lot. It's $270,000 on average per professor. So research is an expensive proposition, and we have many prestigious chairs associated with it, and lots of really terrific research centers and institutes that hopefully you'll get a chance. And that actually makes a significant contribution to the Hamilton area. And I think I have another slide that comes up a little bit later. In terms of that research intensity, we're actually the #1 in Canada. So we're by no means the most famous engineering school, but we do more research than anyone else in Canada. This is for the whole university, a recent Times Higher Ed measure of global impact, and I'll talk a little bit about how they did that measurement. McMaster was actually #2 in the world. In the most recent rankings, this is a little bit out of date. We dropped a little bit, but we were still in the top 20. And considering there's about 20,000 schools that are participating in that, being in the top 20 is a very special category. And then overall, again, this is the university ranking. Again, across all measures of the quality of a university, we rank somewhere in around 70. And really, that's a remarkable number for a place like McMaster, as small as McMaster is, that we're in that good company. The other universities ranked around us are much more famous. So again, some of these ranking numbers, the Shanghai rankings is one that we often look at. They look at all the details and really drill into the different specializations. And you can see the whole raft of areas where McMaster ranks very highly. So all of this is to give you a sense. Our dean said that, McMaster students should have some swagger, right? They really should be very proud of their school. And I can tell you that a McMaster undergraduate, in terms of their attractiveness as a potential graduate student, is absolutely considered at the top of the class. So colleagues of mine who are at Stanford, MIT, Harvard, if they can get a McMaster graduate as a graduate student, they're delighted, right? Because of the excellent training, the excellent quality of the students that we attract, and the type of training that you get during your program. And in particular, the fact that we have this summer research experience. So, sorry, this is kind of a little bit out of order, maybe. Where does that money come from? It comes from a whole raft of sources. The largest single place is the federal government, but we also are the leading school in terms of attracting industry funding or corporate funding. And for us, that's very important. That's an important milestone. It actually triggers some of the other funding that we get, but it also tells us that we're doing something that's relevant. The not-for-profit is also very important to us, because that's often a way that we're able to do research that really contributes to society in ways that we wouldn't be able to do with our industrial partners. And of course, the province is a great donor to our research. And so here's where you can see those numbers, that how they've come up in the last 5 years. And there's a few other things here where the number of patent disclosures and patent applications, and also companies that are being created. These are all increasing very rapidly. In fact, on the innovation front, I would say we're not increasing linearly. It's more like an exponential increase at this point in time. And so here's something that probably, unless you've heard me speak before, you might not have realized. With over 250 students engaged in research each year, we're one of the largest cohorts of undergraduate researchers in Canada. In fact, we're the largest in Canada. We've asked the other engineering schools how many they have. University of Toronto is close in terms of absolute numbers, but we're actually larger and a much smaller school. So it's something we're particularly proud of, that we involve our undergraduates in our research mission, and we think that has benefits throughout the faculty. The other thing that you might not have known is that we've taken to labeling our research activities according to the UN Sustainable Development Goals. If you're not familiar with that, I would encourage you to look them up. It's a group of 17 different goals that need to take place in order to make life on the planet more sustainable. Things like improving water quality, but also social equity. And these, it sort of serves as a framework for us for explaining the big goals that we have and the big types of things that we're working on. So I'll just briefly describe the projects that are sort of highlighted here. Some of you will know Jim Cotton, who's a faculty member in mechanical engineering. Jim's big idea is to think of energy production a little bit more like the way that the internet works. So to have distributed energy production, and not to separate out electrical production from thermal production, but to think of those two as a coherent system. And by doing that, by producing energy through renewable sources, or in some cases by what's called a peaking plant that uses a gas turbine, he's able to provide much greater resiliency to the power, because if one community's power goes out, it can take it from adjacent cells that would be other communities, but also to reduce the carbon footprint of electrical production by 60%. And so this is a big project that's currently going through trial phases. That is, we're going to be doing this at scale to show that those theoretical solutions can actually be achieved. And an interesting point that McMaster students, especially once we all get back on campus, will be proud of. One of the first places where we tried Jim's ideas out was in the Hatch Center. So there's all kinds of technology woven through that little building, which demonstrated and enabled this much bigger investment that's to come. Zina Plazani-Dost is a relatively new researcher here at McMaster in chemical engineering. Her research is fascinating. She's using something called microphage. And this is one of the big things that she's going to be able to do with these, is to develop new approaches to overcome antimicrobial bacterial resistance. That is, these bacteria that really create huge problems in our hospital and healthcare system. This is a new approach that's going to allow us to overcome those challenges. Chin Fang, a friend of mine in my department, engineering physics, is the lead architect of what we sometimes refer to as the Westdale Home. The Westdale Home is a house that's being outfitted with all of the latest technology to enable people with infirmities or elderly people to be able to continue to live at home while getting state-of-the-art assistance in healthcare. And then finally, and I've got to remind myself because on my screen I can't see it. Okay, Sarah Dixon. Sarah's area of expertise is in environmental engineering. So she's in the civil engineering department, and she's one of the leading researchers in Canada that's helping to provide clean water to remote communities, and in particular to Indigenous communities. What you might not have realized from the news is that almost all of those challenges that we face for providing clean water to remote communities, they're all unique. And so they all require somebody to come up with a ingenious solution that's customized to that particular area. And Sarah has just become really adept at building relationships with those communities and then being able to address their issues. So we see education, innovation, and research all as being linked together, and also linked to our communities, the Hamilton community of our students, and the global community. So think about things that way. Think about wanting to try out things in Hamilton and to partner with Hamilton. And we actually have a great relationship with the City of Hamilton. I meet with the innovation officer for the City of Hamilton about once a month to brainstorm ideas that we can work on together. So you're going to hear from Katie, so I won't go into any great detail, but the number of patents and patent licenses and all of those important measures are increasing dramatically. What I'll tell this group is, one of the things that we found really surprising that I noticed about 4 years ago, were all these names showing up on our patent applications that I didn't immediately recognize. So with a little bit of research that I did, I found out these were all undergraduate students. And so I can't tell you this for sure, but I have a very strong sense that we are one of the leading schools, if not the leading school in North America, in terms of having undergraduate students be inventors on patents. And so think about that as you're going through your summer. And then this is actually, and now I'm going to be completely honest and share something with you. This is actually a slide deck that I'm going to use tomorrow when I'll be talking to another important group, which is the new faculty that have been hired over the past year, and talking to them about orientation about McMaster. There's a few slides that I dropped off that I didn't think that you would be interested in, but this one I thought I would keep, which is we advise our new faculty to to strongly consider having an active online presence, to develop, whether you choose to use Twitter or other, it doesn't really matter. LinkedIn has become a very, very popular and important one. ResearchGate, which isn't listed here, would be another one that's specific to research. But think about establishing these things at this point in your career. I would actually strongly recommend you think about reaching this and getting into the habit of talking to people about the research activities you're doing and explaining to them, and also reaching out to other researchers who are at other universities, students, even faculty, and getting their insights, little snippets of advice, and start to build that network out, because that's where things are going. Back when I was getting started, your reputation was built by people reading a journal article that you had published 6 months, 2 years ago, and then maybe connecting with you at a conference or something. Now things are much more fast, much more fluid. Get engaged with the research community and start to become active that way. And then finally, I'm going to encourage you to think big. Talk to your supervisor, talk to the students, the graduate students that you're working with. What are the big goals that are behind the research that you're doing? I mean, why are you cleaning that test tube? Why are you trying to wire up that circuit? Why are you writing that piece of code? So that you understand where it fits into the grand scheme of things. And then if you feel that you have a terrific story to tell, I'm asking you right now, Sarah Novozedlik is in, and reach out to her or myself, and we'll hook you up with a terrific communications team that we have here at McMaster. They can help amplify your social media, but they can also, we also love to write stories about great successes that our students have had. So with that, I'll sort of close my comments and turn you over to the two main stars of this show. But I will stick around and I'll be available to answer any questions that you might have. Back
Thank
to you.
you so much, Dr. Preston, for that. Thank you for that lovely introduction. And now I would like to pass it over to Katie Harding.
Thank you. Hi, everybody. I'm just going to pull up my screen here. Bear with me just a moment. Okay. Hopefully you're all seeing my slide deck now. Yes. Okay, cool. Great. So my name's Katie and I am McMaster's Engineering Librarian. So my job is to help engineering students learn how to do research, how to work with different types of information. And one of the types of information I talk about a lot is patents. So I'm really happy to be here with you today to chat about patent research and some strategies that might help you if you're looking to get a patent, or even if you aren't. Planning to talk about today, we're going to start with a very quick review of patents and patentability, and then we'll look at patent searching, which is going to be important for determining if your invention is patentable in the first place, right? So we'll talk about which databases you might search, some strategies for searching for patents, and also about patent classification, which is a cool topic. So one of the many things I love about talking about patents is it provides me with an opportunity to provide a legal disclaimer. So I am a librarian and not a lawyer, and so none of what we talk about today should be construed as legal advice. This is all just for educational purposes, okay? All right, so let's talk about intellectual property. So the World Intellectual Property Office describes intellectual property as creations of the mind. So this can be everything from works of art to inventions and computer programs to trademarks and other commercial signs. So intellectual property, or IP, allows creators who might be inventors or artists or businesses to control the use of their work, and hopefully in a way that benefits both the creators themselves and also society as a whole. So we're going to focus today on patents, which of course apply to inventions of new products or processes or improvements to either of those. But some of the other types of IP you might encounter are things like copyright, which is used for expression of ideas. So if you think about like a song or a novel or a film. There's also trademark, which are words or symbols that distinguish the goods or services of a particular enterprise. And there's also industrial design, which refers to ornamental designs of a product. Just for some context, but we're obviously going to focus on patents today. So what does a patent do? In countries where a patent has been granted, and this is important because a patent in one country doesn't offer protections in another country, but in countries where a patent has been granted, the patent holder has the exclusive right to the invention being patented. So they can make, use, sell, and distribute the invention, and others cannot. If someone is infringing on a patent, the patent holder can seek damages. And the patent holder can also license the rights to their patent if they choose to do so. Okay, so in Canada, there are 3 criteria for patentability. In other countries, the laws might say this a little bit differently, but the criteria are often quite similar. So the first criterion is novelty. The invention must be the first of its kind in the world. The second is utility. So the invention actually has to work and have a useful function. And the final criterion is inventiveness. So the invention must be something that's non-obvious to someone working in your area of specialty, to the average person doing that kind of work. And these are all important. The most important one when it comes to patent searching is novelty. So if you want to obtain a patent for an invention, you'll need to verify that it hasn't already been patented somewhere else in the world, right? So I just wanted to show a quick example of a Canadian patent. Patents tend to have a similar structure. So if you look at a patent from the United States or from Europe, they will tend to look quite similar to this. There's a lot of information in a patent, especially on the first page where you'll find things like the title, the patent number, some important dates for the patent, the inventor, the owner, things like that. They'll also have a representative drawing and an abstract, much like a journal article has an abstract. And then after the first page, you will find some more detailed drawings of the invention that really lay out what you're looking at. You'll find a list of the patent's claims, which outline what the elements of the invention are that are being protected by the patent. And you'll see the specification, which is a really detailed description of the invention and explanation of the drawings that you're finding in the patent. Okay, so that was the quick review of patents and patentability. And now I want to really get into the different types of patent search and how we might approach those. So there are different types of search that you might conduct depending on your needs, what you're trying to do, and you would approach those differently. So in a state-of-the-art search, you might want to know what inventions exist to do something, right? You would want to search across all countries, but it might not be hugely important if you miss something, if you're just interested in finding out like what technology is out there. In a patentability search, you want to know if your invention has been patented already. And like I said before, you need to know if it's been patented anywhere in the world. So because if it has, you can't get the patent. So this is a search across all countries where it's critical that you identify all relevant patents. You want a really, really thorough search. In a freedom to operate search, you just need to know if something is patented in a given country or a group of countries where you hope to operate your business. So in this case, you need to do a really thorough search, but only in the countries where you're planning to operate. So before you start searching, it's important to think through what kind of search you're doing, because that'll inform how you approach it. Okay, so your next step is going to be to identify which databases or other search tools you're going to use to look for patents. You can search directly from individual patent offices, so like the Canadian Patents Database. The other 5 offices I've listed here are the big 5, the largest intellectual property offices in the world: China, Europe, Japan, South Korea, and the United States. And so those are some you might encounter as well. There are some other free patent tools that allow you to search across different countries. I've listed a few here. I often point people to Google Patents just because it's a really familiar interface that's really easy to use. But you can experiment with some of the different tools that are out there and figure out what works best for you, what features they have that are helpful for the kind of search you're doing. If you need to do a really thorough search, you might end up using a combination of these, right? You might be searching in the relevant countries database and also using like a free tool to search more broadly or something like that. So one of the ways that you might search for patents is by inventor or assignee. So of course, the inventor is the person or the people who had the idea for the invention and developed it. But the patent will also list an owner, or they may be called an assignee, and that's the person or the enterprise who owns the patent. And this can change after a patent's issued, so it may not necessarily be accurate on the patent or in the database where you're searching. These are really quite easy searches to do with Google Patents. You can search by inventor or assignee and put in the name you want to search for and bring up a list of their patents. And it's sort of just a fun thing to see what companies are doing, what certain people are working on, what kind of patents they're filing. Another way of searching for patents that you might try is a keyword search. So you'll want to be careful in choosing your keywords and make sure you do things like trying out different synonyms and related terms, because it's hard to know exactly what words someone might use to describe their invention. And there are some real challenges with keyword searching for patents. So they may use some jargon that's difficult to understand or to search for. Brand names are often not included in the patent, so you can't always search by a brand name. And the big one, they may use a lot of words to say something that's actually quite simple. So I have this patent title here, dry mix compositions, including corn syrup and methods of preparing baked goods, such as cookies and brownies therefrom. And like that's the title of a patent for a brownie mix, right? It's really quite a simple thing that's described in a whole lot of words. And some of that's by design, right? So patent lawyers will try to write a patent to have the most broad application possible, which can lead to some really strange and unintuitive wording when you're looking through patents. And what all of this means is that keyword searching is not enough. So if you need to do an exhaustive patent search, if you're trying to find out if your invention is patentable, a keyword search is not going to be sufficient. And this brings us to patent classification schemes. So this is a much more thorough approach to patent searching. These are very, very detailed systems that classify patents so that patents for similar technologies are grouped together and easily findable. So it deals with this issue of keyword searching, because when you search by classification, you don't need to know which terms the patent used. And it also allows you to find patents that are published in other languages where you might not know what keywords to use either. There's a few different classification systems that are used by different offices. And the international patent classification and the cooperative patent classification systems are the two you're most likely to encounter. But you may need to use a different one, again, depending on what you're trying to accomplish and what countries you're planning to work in. And so I just wanted to share an example of a code from the International Patent Classification System to show you how this works. So I found a US patent for a wearable heart rate monitor. And it lists this IPC symbol A61B5/024. And so you can see that we can break this symbol down into something that means something. So the first part of the symbol shows the section. There are 8 possible sections in this system. And the patent is in section A, which is for human necessities. So anything that could be considered a technology related to human necessities goes into section A. The next level is more specific, and that's the class. And this class is A61 for medical or veterinary science or hygiene. And you can see these levels just keep getting more and more specific until we get to the actual code itself, which falls into this subgroup A61B5/024, which is for technologies that measure pulse rate or heart rate. So really the system is classifying the patent into increasingly specific categories. And at the end, you find this complete IPC symbol, which should provide all the patents for inventions that measure pulse or heart rate, which is really useful. And so patent classification can be really helpful if you're trying to do a thorough search. And it's something I highly recommend if you're doing any kind of a patentability search. And I'm going to wrap up now. I know this was a lot of information, and I'm happy to talk more about this with any of you. So please feel free to email me any questions, or you can email me and set up a time to meet and talk more. I'm happy to help you with patent searching and with strategies for finding patents and with strategies for reading patents and finding the information you need. But like I said, I'm not a lawyer. So there are things that I legally cannot help you with. Things like interpreting information that you find in a patent, or helping you determine and decide if your invention is patentable, or helping you actually file a patent application. Those are things beyond what I can do. But please do get in touch and let me know if there's anything that I can help you with. And with that, I'll just say thank you for listening to me. I'll turn it back over to Sarah.
Thank you so much, Katie. Thank you. So that was a great introduction just to patents, and now we're going to hear from someone who's actually gone through the process of taking an idea, working through a patent, and taking that design into a business. So take it away, please.
Rookie Zoom move. I was muted. You would think after like 2 years. Okay, so I'm assuming you guys can see my screen. Okay, perfect. So hi everyone, my name is Liana Genovese. I'm the CEO and founder of Imaginable Solutions. So we create assistive devices to improve the quality of life for people living with impaired motor movement. So I'm going to tell you a little bit about my story, how I became or how I went from researcher to CEO of a company, and the lessons that I learned. Okay, so my journey began in my first year at McMaster University, studying as a biomedical and mechanical engineering student. So I'm in the iBiomed program. And I met Alyssa, a woman living with dystonia, a rare type of cerebral palsy. Before her condition worsened, she was a talented painter, but now she experiences the uncontrollable curling of her fingers called hand spasticity, and she was not even able to hold onto a paintbrush. So Alyssa had lost her confidence, her passion, and her creativity. So as part of my school project in the 1P10 class in the iBiomed program, I had to create Alyssa something to enhance her life in any way. So I was inspired to create the first prototype of guided hands to help Alyssa paint again. And I'm not sure if I mentioned, guided hands is the name of my product. So I found inspiration from a 3D printer. I imagined a 3D printing nozzle as a hand that could move in all directions. So I went straight to drawing, and clearly, as you can see, I am not an artist, and I had a really hard time drawing what was in my head, and I went straight to prototyping. So the first prototype was made out of local hardware supplies. I used the ball of yarn and a paint roller, but it worked. Alyssa's passion was reignited and she was able to paint again. And my prototype also won first place in a national competition. And after that, I was motivated to continue my project and see how many other Alyssas I could help. So the next summer, I had an engineering co-op at McMaster Manufacturing Research Institute, and my supervisor allowed me to stay after hours to use their machinery and 3D printers to transform my prototype into a finalized device. So I redesigned, manufactured, and invented guided hands. And I wanted to see if it worked, so I made a list of every single hospital clinic, rehab center, nursing home, and retirement home in Hamilton. And at the time, I didn't own a car, so I bussed across Hamilton on the HSR with guided hands in a garbage bag, since it was the only wrapping I could find. I knew it was a risk to go to respected medical institutions with this packaging, but regardless, I stood in front of over 150 patients and physicians and did the grand reveal of taking off the garbage bag and introduced guided hands. I saw their excitement and happiness. Patients quickly mastered the device, and I gathered incredible feedback. And then I met Bella, a 12-year-old living with cerebral palsy. She experiences the same curling of her fingers as Alyssa, and Bella tried guided hands at McMaster Children's Hospital. As soon as she began painting, the widest smile spread across her face. She first painted, then used a pencil, and then used an iPad. She turned to her mom and said, "Mom, I want one." And then the mom turned to me and asked, "How much is it?" And at that point, the thought of even selling the device had never crossed my mind. But in that moment, I knew I had found my passion and that I had to bring this product to the world and help others like Bella and Alyssa. So a week later, I incorporated my company, Imaginable Solutions. Now, I want to introduce you to one more person who played a very important role in my journey, and also to visually help you guys see what limited hand mobility is. So I met a boy named Elijah, a 10-year-old who also lives with cerebral palsy. And in this video, I ask him to write his name, but he struggles to write the first letter because he has limited control in his hand and arm. So as I sat beside him and watched, I was heartbroken, but also motivated to help him reach his full potential. I then realized that Elijah had many pain points and he experiences the same pain as other children. Every day they are reminded of their condition from friends or even an older sibling as seen in the photo. Elijah is unable to express himself creatively. And since writing and drawing is a way that children often communicate and connect with the world, Elijah feels socially excluded and frustrated. So I was able to clearly define what the problem was. And I soon learned that Alyssa, Bella, and Elijah are not alone. They are one of 58 million people in North America of all ages living with a medical condition that impairs their hand mobility. So this is known as market research. And our goal is to bring these individuals guided hands, an assistive device that enables people living with limited hand dexterity to write, draw, and paint. It also allows them to access technology and type and scroll on a tablet, phone, or computer. And our technology uses a system of linear ball bearings and shafts to create a unique sliding system that guides hand movements in all directions as the user holds a handpiece tailored to the level of hand impairment. So you can kind of see where I got my inspiration with 3D printer from. So this is essentially the basis of our Canadian and US patent, which Katie spoke about earlier. So we also filed for patents, and we also filed for trademarks for the names Guided Hands and a Magical Solution. So I can definitely talk about my experience with that. It's definitely long and I had to learn a lot, but it is definitely worth it. So Guided Hands improves quality of life through enabling communication, development of cognitive skills, promotes independence, and allows the user to do what they love. So after innovating, my next step is to research what other products were in the market and find out what our competition was. So our competitive advantage is functionality. So competitive advantage means what is the one thing that stands out from the other competitors. So 3 competitors have only one feature. They can hold a writing utensil, but they don't control and guide hand movements. The most expensive product focuses on Parkinson's disease. It controls hand tremors, but it still relies on the patient to hold writing utensils, which is often too difficult. And lastly, none of our competitors accommodate for the user's varying levels of hand impairment. So Guided Hands is the most supportive for the hand and arm, which users say reduce hand fatigue and pain, and it holds any type of utensil. So as a solo female founder with no business background, I made a point to surround myself with a team of researchers, advisors, and collaborators. Early on, when I met with a patent lawyer to get the patents for Guided Hands, I did not understand any of the legal terms he used. I wrote them down and Googled them later. I knew I had a responsibility to educate myself and fast. So I reached out to the Forge, McMaster's business incubator, and I found time in between taking 7 engineering courses to attend workshops and coaching. So the first thing I did was attend their startup school. So this was something that I did at night once a week. And again, I learned all the basics to business. At the end of the day, I knew what the lawyers were saying at my next meeting. The second thing I did was attend or apply to the summer startup competition. So you have to do a written application, and then you do a quick pitch as in presentation, about your company or about your idea. When you go to the Forge, you don't have to have a physical prototype. You can just go to them with an idea. But now this is a competition to win real money. So I actually placed second in the competition and won, I think, $11,000 it was. And then the third thing that I did with them was attend or be a member of the business incubator. So I just wrapped that up a couple weeks ago, but in this business incubator, you get some funding and you still get some mentorship and you still get workshops and trainings, which is so helpful, especially for myself since I had no business background. And if you need me to explain anything more with the Forge, I'm happy to at the end of the presentation as well. So aside from the Forge, I joined AgeWell, which is another incubator, the Clinic, which is McMaster's more health science incubator, and the Innovation Factory, which is another resource that you can reach out to. It's not for McMaster specific, but it's with Hamilton. So any Hamilton company, or even if you're not incorporated as a company and did the paperwork, you can still go to them for help, and they'll pair you up with a mentor, and they do an amazing job there as well. So now with all of those people helping me out and all those incubators, I was able to form a go-to-market strategy. And a go-to-market strategy is essentially how you plan on selling the product. So for instance, for me, we create awareness for guided hands through medical associations, healthcare facilities, and schools in Canada and the US. So we sell guided hands directly to hospital clinics, rehab centers, where we offer volume pricing. And we also sell directly to customers on our website, and they're referred by their association, their occupational therapist, or educational assistant. So as a new company, I didn't have any money. I entered into every single competition I found on Google to win prize money to fund my business and create awareness for guided hands. It worked. We raised $91,000 and my company got media attention locally, nationally, and globally. And as a result, we got some press in the local newspaper, radio station, and TV. And leading healthcare systems across Canada and the US have reached out to us to use guided hands with their patients. And I mentioned this earlier, but the reason why I'm doing these pilots is to not only create awareness for guided hands, but to also receive feedback from healthcare professionals, since I'm not sure if you guys learned this in class, but design is always an iterative process. We're always continuing to make improvements to our product, even today. Actually, I'm going to Alberta tomorrow to visit one of the rehabilitation centers in Edmonton to do a pilot of guided hands. So it's definitely important to get so many different people of all ages, all medical conditions, in all areas to test the product to really identify that you're solving the problem. So quite frankly, I didn't go to school to become an entrepreneur. I went to school to become an engineer, but it made me one anyway. So I guess entrepreneurship was in my DNA. But now my life is super busy. Most days I feel overwhelmed, but what inspires myself and my team are these smiles and the ability to change someone's life. Imaginable Solutions improves the quality of life for people living with limited motor movement. People like Alyssa, Bella, Elijah, and 58 million others across North America. So I'm near the end of my presentation, but I want to tell you a few lessons I learned. So the first is surround yourself with other entrepreneurs. So you'll quickly realize that when you're in entrepreneurship that you will experience the same problems and the same challenges as other people, despite being in different industries or having different products, and having a support network is invaluable. The second is be able to flow like water. So when you come face to face with a challenge or a barrier, you got to find out how you can navigate around it, who you can reach out to. And you really have to be able to pivot yourself so you don't stop. You just have to keep going. And the last is transform your passion into a profession. Find what gets you excited and do it every day. Even if you face a challenge, you will have the fight in you to overcome it. Now, to end it off, I'm a huge fan of the movie Rocky. For those who haven't seen the movie, in my opinion, it's one of the most inspiring movies out there. I made my family drive 8 hours to Philadelphia just to take a photo with that statue. And my favorite line is, "It ain't about how hard you hit. It's about how hard you can get hit and keep moving forward." And that is the mantra I continue to follow today. Along my journey, I've been put down for being a student, being young, for being a woman, and I faced many business challenges and barriers. Don't let anyone dictate who you are and what you're capable of. Define yourself. If you have a passion or an inspiration, you gotta follow it and drive towards it. But sometimes you have to be willing to take the hit, but you always have to remember to get back up even stronger. So thank you so much for having me. I'd love to answer any questions or share any more experiences with you all. I would like to add in that if anyone knows of anyone who could potentially benefit from using guided hands, don't hesitate to reach out to me. And I'm also going to put in a plug that with the Club Med T, we will be onboarding general members and a project manager to the company with our partnership with McMaster Med T again. So if you want to know more about that as well, just don't hesitate to reach out. And that is my contact information. Feel free to message me on Facebook as well. But yeah, so thank you guys so much.